at the anode, we are going to find that this zinc here, the zinc electrode, will start decomposing. Actually, it will dissolve in the electrolyte once the electric current passes through it. And as it dissolves, it will decompose or ionize.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is ZnSO₄ Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored for competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together.
This time, let's give another example. We are going to use again active electrodes. So we are going to look at electrolysis of zinc sulfate solution. We are going to use zinc sulfate as a solution, but this time we want to, let's assume this company is making iron, making these test tube holders out of iron, but they want it to give it a shiny appearance of zinc. So what we are going to do, we are going to use iron as our main element, material that is going to make the metal, and then we coat it with zinc to give it this shiny appearance. So what we are going to do, we are going to use, we said what we want to coat is used as the cathode, and what we need to put around that substance we want to coat as the anode. So we are going to use zinc as the anode, because it is done to plate on, let's use iron. Any iron material you want to coat, to electroplate. Let's say iron padlock as the cathode. So looking at the application of the previous explanation we had. So in this one, simply, so this is our electrolytic cell. Our electrolyte is zinc sulfate. We are using the electrodes. We are going to have, this is our padlock. Let us assume this is our padlock. We want to electroplate it well with zinc. So what we do, we shall make sure that this zinc is taken as the anode, and then our padlock will become the cathode. So this is our cathode, the iron cathode. We want to electroplate this iron padlock cathode, our iron padlock with zinc. So we use it as the cathode, and what the metal we want to put around the other material, we use it as the anode. So this means that the electrolyte, they are the other ions we talked of. Since it is a solution, we are using active electrodes. These two are active electrodes. Because these metals, both these metals can conduct electricity, can involve in ionization. Carbon cannot ionize. So the cations present, we have the hydrogen from water and the zinc from the zinc sulfate solution. And then the anions we have the hydroxide from water and the sulfate ions. Since we are using active electrodes, we shall not talk of the anions at the anode. Remember that the anions migrate to the anode and the cations migrate to the cathode. The ions migrate to oppositely charged electrodes. At the anode, we are going to find that this zinc here, the zinc electrode, will start decomposing. Actually, it will dissolve in the electrolyte once the electric current passes through it. And as it dissolves, it will decompose or ionize by loss of electrons, to form zinc ions in the zinc sulfate solution. That is at the cathode, at the anode. The zinc will lose electrons. It will lose electrons to form zinc ions. So, such that at the cathode, so this means we shall note some decrease in the size after electrolysis. After some time, we shall note a decrease in the size and change in the shape of the anode as a result of decomposition of it. And then they formed at the cathode. The ions, the zinc and hydrogen ions, will migrate to the cathode. So we have zinc and hydrogen ions. But which of these two will be discharged this time? The zinc ions were not much concentrated, but as a result of forming more of them after the decomposition of the anode, the amount of the zinc ions increased. That is one factor. And this implies that they will be discharging in preference of hydrogen due to their concentration. That is one, and due to the nature of the electrodes used. We used active electrodes. So this means, however much the hydrogen is less reactive compared to zinc from the reactivity series, but zinc is more concentrated due to this more of the ions formed from the from the anode. So we have more of the zinc ions migrating to the cathode than the hydrogen ions. So this means the zinc ions that will be discharged by, this is gaining of electrons, which is reduction. This one was oxidation. By gaining of electrons, which is reduction, to form a gray solids of zinc or shiny gray solids of zinc depositing around the iron padlock. So we shall note some increase in size of the padlock as a result of the zinc coating around it. This I'm using a padlock here, but next time they may use another material. So long as they are active electrodes, not the graphite, not the platinum. So long as they are using any active electrode, it implies that the anode will decompose into ions, like we are seeing that. And then the ion is formed both from the electrolyte and the anode will migrate to the cathode, and they will be deposited by discharging them in preference of the hydrogen ions. So this is an application. So the electrolysis of an electrolyte using active electrodes is greatly applied in the electroplating of metals. So there is also electrolysis. We may think of any other. We may use lead here. We may use copper, electroplating something else. We may use silver, electroplating. So long as we change, we may use silver anode, and then we use maybe silver nitrate as our electrolyte. And any other material here we need to electroplate as the cathode. So long as whatever you want to coat is used as the cathode, and what the material you want to put around the other one used as the anode. Hope I'm clear. And then there is also electrolysis of acidified water, or electrolysis of dilute sulfuric acid. But before we go into that, we should not forget that the products at the anode will change if these electrodes are not active electrodes. If we use graphite or platinum, however much we are using zinc sulfate, the product at the anode will change, like we said on the other one of copper. For this electrolysis, if the electrolyte used is dilute sulfuric acid, we mostly use the inert electrodes, the graphite electrodes. And in most cases, we shall find that the electrolyte we are talking of is dilute sulfuric acid. So this means that being dilute, it was dissolved in water. It was diluted with water. Meaning that we have cations and anions. The cations in it, we have hydrogen from water and the hydrogen from the decomposition of the acid. And then the anions we have the hydroxide ions from the decomposition or ionization of water, and the sulfate ions from the ionization of the sulfuric acid. Members, this electrolysis will also involve migration of ions to oppositely charged electrodes, where let us assume this is the cell. We have the two electrodes, completely covered in a gas jar, each of them completely covered in a gas jar. Even the gas jar filled with the electrolyte. of the same amount. So this is a gas jar, this is also a gas jar. This one connected to a positively charged plate or terminal, and this one to the negatively charged terminal. If the circuit is complete, we shall find that this sulfuric acid will decompose to give those ions. And we shall find that the hydrogen ions from water and the hydrogen ions from the acid will migrate to the cathode. Since the ions are of the same kind from the same element, they will all be discharged. So you have more of the hydrogen ions in the electrolyte than the anions, the hydroxide and the sulfate anions. So the discharge of the hydrogen ions will take place at the cathode, and it will be by gain of electrons. And this will be resulting into formation of hydrogen gas. Since we have more of the hydrogen ions in the electrolyte than the anions, because the anions are of different kind, we shall be forming, assume the gas jar of the same height, we shall be forming a lot of hydrogen gas at the cathode, negatively charged plate. So we shall form more of the hydrogen gas from the many hydrogen ions being discharged by gaining of electrons, which is reduction. And then at the anode, both the hydroxide ions and the sulfate ions migrate to there. But since we don't have any other factor like activeness of the electrodes and concentration of the ions, we shall base on one factor, which is position of the radical in the reactive series. Meaning that we shall discharge at the anode, we shall discharge the hydroxide ions. And remember the equation for the discharge of the hydroxide ions as this. So this one will be discharged by loss of electrons, forming oxygen gas and water. We remember this equation. So this means that at the anode, we are forming oxygen. But since the oxygen we are forming is only from the little amount of water in the acid, so we expect to form less of the oxygen compared to the let's make it more clear. More of the hydrogen will be collected, so much space of it will be occupied by the gas, and we shall be collecting less of oxygen. So this is the amount of oxygen, this is the amount of hydrogen. A lot of it is, the acid is displaced by the gas, which is hydrogen. More of the hydrogen is formed, and we are forming less of the oxygen, so the biggest space will be occupied by the electrolyte. So in this electrolysis, we form less amounts of oxygen, more of hydrogen, for the reason we talked about. More of the hydrogen ions in the electrolyte. Hope we are talking. So this is greatly applied during the preparation of hydrogen, and we know that hydrogen is a great fuel used in daily life, like operating engines of spaceships and so many others. The battleships, the battle planes, battle jets, most of them use hydrogen as fuel. So the hydrogen is also used in batteries as a fuel. So this is also of great application. But this should be noticed that we form less of the oxygen, more of the hydrogen. The reason should be known. Remember, this is ZnSO₄ Online. We are always here to give you reliable information, free of charge. All you have to do is to subscribe, to invite more of your friends, to like our videos if you really like them, by tapping that thumb and pressing the bell for more notifications. Teacher Alan.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is ZnSO₄ Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored as a competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together.